In these notes, we're going to talk about similar solids and ratios again of how sides, surface area, and volume ratios compare. So first off, our similar solids are when we have two solids of the same type with equal ratios of corresponding linear measures, sides, heights, radii, etc. So our scale factor, remember, is when we have a common ratio, which just means that the ratios are the same, of one solid to the other. So all cubes are similar to each other, and all spheres are going to be similar to each other just based on the fact that they only have a radius or diameter, and cubes as well. They all have to be the same sides, same lengths to begin with for your length, width, and your height. So here is an example of similar solids versus non-similar solids, and it's mostly because of the height part of it. The height is the same, but the radii is changed. Versus this one, the radius changed and the height changed. So we know in the second one that they are not similar because we have to have all pieces changing at the same rate. So one thing we're going to talk about again is scale factor. So if two similar solids have a scale factor of A to B, or sometimes you might see it as A over B. We use it for proportions. The corresponding areas have, so areas have A squared to B squared. The volumes have a ratio of A cubed to B cubed. So make sure you take note of that, how they're different to each other. So the sides themselves, so the scale factor is our A to B. The area is A squared to B, and the volume is A cubed to B cubed. So if we're looking at our pictures down here, you can see that it is set up the same way. So our scale factor for the sides is going to be A to B. So you might want to do this to make a little chart for yourself. The area, or mentioning surface area, would be A squared to B squared. And then volume is going to be A cubed over B cubed. So we've seen this briefly before with scale factors, but we're going to see it again. So on these, we're going to tell whether the prism over here on the right side is similar to this one, and then we're going to go back and figure out if it's similar to the second one. So what I'm going to do first, just to help us organize, this can be my length, my width, and then my height. So this would be my length, my width, and my height, and my length, width, and height, so I can compare them correctly. So for this first one, to compare my lengths, I'm going to do the small one to the big one. So I'm going to do the original one to my second one. So I'm going to do 4 over 8, and if I reduce, that becomes 1/2. So I need to check all three of these to see if they are the same. That's how I can check to see if they are similar to each other. So next I've got 2 over 4, so that becomes 1/2. And then with my heights, we got the original one, my 2, over the new one, which is 2, and that gives me a 1. Since they are not the same, then this tells us they are not similar. Okay, so for the next setup, we're going to do the same thing. So we're going to do our lengths again. So 4 to 6 reduces to 2/3. Next, my width, I'm going to do my new one, or my old over the new, so that'd be 2/3, that just stays 2/3. For the height, my old is 2, my new is my 3. So if you notice, they are all the same, so the ratios are the same. So yes, they are similar. And then that means that our scale factor is that ratio that we just found. So it'd be 2 to 3. These two questions are very similar, so we just have them side by side, and we want to know, are they similar to each other, and then explain why. So again, we need to identify kind of how we're going to set it up. I'm going to have length, width, and height again. So length, width, and height, so I know how I'm going to pair them up. So my length will go first. I'm going to do 12 over 9, so just left over right is how I'm going to do it. And that's usually how I do mine. So if I reduce that, let's see, 3 goes into both of those, so that'd be 4 over 3. Next would be my width, so 16 over 12, and 4 goes into both of those, so that'd be 4 over 3. Height would be next, so left over right, 4 over 3, and that just reduces to be the same thing. So you can see that all of these ratios are the same. So that means, yes, they are similar. And then my scale factor again would be the 4/3 that we found. All right, so our next figure, I've got the radius is my 10 and my 5, and then my height is my 15 and my 10. So let's do the radius. Again, I'm going left over right. So I'm going to do 10 over 5. That reduces to 2 over 1. And then my height, I've only got 15 over 10. Let's see, 5 goes into both of those, so that would be 3 over 2. And since these ratios are not the same, then that means that they're not similar. Make sure you're putting the reason why as well and not just saying that they're not similar. Now that you know more about scale factors, we're going to go into how we can use them to solve some different pieces and how to find different scale factors. The scale factor is just based on the sides themselves, or one side length. So if we go from scale factor to the surface area, we need to square the numbers. If we go from scale factor all the way over to volume, we need to cube the numbers. And then the exact opposite, we would have to take the square root. So if I go from surface area back to the scale factor, I would have to take the square root. If I go from the volume back over to scale factor, I would have to take the cubed root, and that's in the math button on your calculator, so make sure you make a note of that so you know where that is. All right, so since we are going from 3 to 5 over to surface area, I'm just squaring them. So 3 squared and 5 squared gives me 9 to 25. If I need to go from the scale factor all the way over to our volume, we don't use this 9 over 25. We always are going to go based off of the 3 to 5. So I'm going to take 3 cubed and then 5 cubed, and that gives me 27 to 125. All right, so now if we need to go backwards, that's what these next ones are going to be. So going backwards from scale factor, from the surface area, I need to take the square root. So the square root of 4 and the square root of 9, I get 2 to 3. Okay, so then I need to use this to find my volume ratio. So I need to cube each of those numbers, so 2 to the 3rd power and then 3 to the 3rd power gives me 8 to 27. So to find the surface area ratio and the volume ratio, you always have to base it off of the scale factor. So next, for my volume ratio, I've got 8 to 125. So if I'm going backwards, I need to take the cubed root. So that would be the cubed root of 8 and the cubed root of 125. So basically I'm asking myself, what times what times what will give me 8? And that will be 2. And then what times what times what will give me 125, and that would be a 5. So 2 to 5. Then I need to use that to find my surface area. So 2 squared and then 3 squared. So then I would get a 4 to 9 as my final. 4 to, I put the wrong number there, 25. So 4 to 25. Okay, so now we can use our scale factors that we've got to find surface area or volume numbers themselves. Okay, so notice this is a scale factor number, so that ends up over here on my chart. So when I want to find the surface area, I need to find the surface area volume, or surface area ratio. So my surface area ratio, I need to take 87 squared and 100 squared, which gives me 7,569, and then 10,000, so 4 zeros. All right, so if I have the surface area ratio, which is 7569 over my 10,000, and if you notice that is small to large. So when I have the small number, and I'm trying to find the large number, my small number needs to go on top, and then my large number needs to go on the bottom. I'm just going to do SA for surface area, so I remember what I'm trying to find. I'm trying to find the surface area of that shape. So we can cross multiply. So if I multiply these together, I get 518,400, and then I still have 7569 times my surface area. When I divide, then my surface area will end up being, let's see, 68.49, and this would be inches squared would be my surface area of the larger. Okay, so I want to do the same thing now for volume. So my volume ratio, I got to take my 87 and cube it, and my 100 and cube it. And these are going to be pretty large numbers, so just keep with me. So 658,503 ... and then this is 1 million. So 1 with 6 zeros after it is 100 raised to the third power. So again, it's smaller to large, so I got to put my smaller number on top, my larger number on the bottom. But then again, this is the small one, and I'm looking for the large. So I got to put my small one on top and keep it the same, and then I'm looking for my large volume. So when I cross multiply, that gives me, let's see, 2827 with 4 zeros equals my 658,503 with my volume. So my volume ends up being, when I divide that, 42.93, and this is volume, so it's going to be inches cubed. On this very last one, we see that the pyramids are similar to each other, and we need to find the scale factor between the two of them. So notice it says the pyramid P to Q. So that's how we're going to write it, or we're going to write it as P over Q. So we're going to keep that in mind when we set up all of our numbers. So now when we look at it, we see pyramid P has a volume of 1,000. So for volume, we've got 1,000 for P, and Q has a volume of 216. But notice this is the volume ratio. And we need to find the scale factor. So what do we have to do with this? We have to take the cubed root of each of those numbers. Remember, that's at the math button in your calculator. All right, so when I take the cubed root of 1,000, I get 10, because 10 times 10 times 10 gives me 1,000. And the cubed root of 216 gives me 6, because 6 times 6 times 6 is 216. And when I reduce that, because we always want to reduce, we get 5 over 3. Or you can write it side by side if you want, so 5, 2, 3.